So starting at down here, moving down to the bottom part of our first page, number 5, 5A and 5B, it says solve the given inequalities and graph the solution set on a number line. Now, these could be particularly interesting, especially because a long time ago I told you if you had the word or, the areas would be apart. And that's not always true. Okay? Most of the time, yeah, the areas are apart. But let's work through number 5 so we could see this special case of a problem here. We really do have like two separate inequalities separated by the word or. So let's just solve both of them. But let's remember that it really belongs to the same compound inequality. So let's start by adding 3. We're going to have 5m is less than 12. And if you divide by 5 and divide by 5, you're going to have m is less than 12 fifths. And of course, 12 fifths on a calculator or in your head is 2.4. So m is less than 2.4. Okay? Now let's do the other one. We're going to subtract 8 and subtract 8. You're going to have 7m greater than or equal to 8. And you're going to divide by 7. Divide by 7. You're going to have m is greater than or equal to 8 sevenths. Which 8 divided by 7 on a calculator is 1.14. So you could just say 1.1. Okay, now we need to also identify the correct graph of this thing. So you're going to see multiple choice answers with the number line representing these guys. So let's say I have 0 right here. Let's say I have 1 right here, 2 right here, 3, -1, and so on and so on. So let's go to this first one right here. Let's do it in blue. M is less than 2.4. So 2.4 is going to be an open circle. And less than is to the left or to the right? Less than is to the left or to the right? To the left. So you're going to be going this way, right? Now, if we go to the other one, I'll go with this one in black here. M is greater than or equal to 1.1. So 1.1 is really close to 1. And it's a solid dot. Agree? Now that one says, let me make the solid dot bigger. That one says M is greater than or equal to 1.1. So that one's going this way. Does that make sense? Yeah. Now, it really does, especially right here on our sketch, it looks like it's an area between here and here. But notice when I say it's an area between here and here, I'm using the word and, not or. So this or right here is very critical, especially on this question. Okay? Because if I had the word and up here, then yeah, for sure, it has to be an area between here and here. But if it's or, what it's really saying is that it could go this way, or it could go this way. Does that make sense? So let me ask you this. Does the number 0 satisfy this answer? 0 does satisfy the answer because it's going 0 is covered in the blue part. See, the word and means that it has to satisfy both the black and the blue. But the word or means that it could satisfy the black or it could satisfy the blue. Right? So the word or, it's kind of like this. If I told you, look, I'm going to give you guys $10 if I roll this dice and it lands on the number 5. You guys cool with that? Okay. And what if I say, you know what, I want to give you guys $10 if I roll this die and it lands on the number 5 or 6. Is that better? Yeah, because if it lands on 5, you win. If it lands on 6, you win. The word or means either one works, right? So the word or in this case is that it could be the black one or the blue one. So in reality, on your graph, it's just going to show this. It's going to show a darkened line going in both directions, representing all real numbers. Because the word or is covering both of them. If it were the word and right here instead of or, then it would be between here, and it really would be just this in between here and here. But the word or means that it could go that way or this way, which implies all real numbers. Does that make sense? Does it make sense? Yeah. Okay. Now, if we go over here, this one does not have the word or. It has the word and. So right there, you would have to just stick between there and there. So let's do this one real quick. Plus 3 plus 3. So we're going to have 5m less than 12. M is less than 12 fifths. Whoa, that looks like an 8. 12 fifths. M is less than, we said that was 2 point what? 2.4. Hold on a second. So we're realizing that it's the same exact question. Again, I forgot to change numbers. But that's actually great, because now I could really focus in on the difference between the or and the and. Okay, so I already know my answers. The one on the left is going to be m is less than 2.4. And the one on the right is going to be m is greater than or equal to 1.1. M greater than or equal to 1.1. And again, if we go to our number line, and we put 0, 1, 2, 3, negative 1, and we go to this one right here in blue, less than 2.4. 2.4 is about halfway. It's going to be an open dot. And less than is to the left. And if you go to the other one, m is greater than or equal to 1.1. 1.1 is super close to 1. Solid dot. And it's going that way. Because it's the word and, it's going to stay between here and here. So it's not going to keep going this way and keep going that way. So it really is between these two guys right here, with a solid dot right here and with an open dot over here. As opposed to the other one with the word or, that was really, you could go that way forever or that way forever. But then the word and over here is between here and here. Make sense? Okay, great. That's only one question on the final. Moving on. Backside of the first question, number 6. 24 questions to go. All right, ladies and gentlemen. First thing you need to do is make sure that the absolute value is isolated. Okay, which it is. So let's jump right to our positive and negative situation. You're just going to rewrite it exactly the way it is without the inequality. Exactly the way it is without the inequality. And for the negative situation, it's the same thing, no inequalities. I mean, what am I saying, inequalities? Without the absolute values. That's horrible. I apologize. Without the absolute values. So notice, it's p minus 3 less than 9. There it is, p minus 3 is less than 9. No absolute values. Same thing over here, no absolute values. We're just going to write the p minus 3. But we are going to flip the inequality symbol and change the sign of the 9. So it's going to become greater than instead of less than. And we're also going to put a negative on that 9. Now we solve both. We're going to go plus 3, p is less than 12. That's one answer. And then plus 3, p is greater than negative 6. That's another answer. Okay, so what we need to determine now is whether these answers are together or apart with the word or. And the only way to determine that is to go to a number line. So I'm just going to go up here and go to a number line. I'm going to put negative 6, obviously on the left side. It's smaller than positive 12, which is on the right side. 0 would be somewhere over here in the middle. And if we look at p is less than 12, less than is to the left. Okay? And the other one, p is greater than negative 6. So it'd be an open circle, greater than is to the right. Now this area is together, so I have to write it together. Now it's really easy to write it together if you did this sketch right here of this number line, because it's already in order, smaller numbers on the left, bigger numbers on the right. So all you have to do is put an X in the middle, put the smaller number on the left, which it's already there, the bigger number on the right, which it's already there. And if you know that this is the smaller number and this is the bigger number, then both inequalities have to open to the right. Both have to open to the right. Okay? So, boom, boom. This is your compound inequality answer for that question. Okay? By the way, 6b is kind of like a trick question again, curveball. Now, what do I mean by that? I mean that there's no solution, because obviously you cannot have the absolute value of something being less than a negative number. That's impossible. So that one's just a quick no solution right there. So we need a graph on number 7. 7a is in slope-intercept form. That's like the easiest algebra 1 type of stuff you could do. So that crosses at -1. Put a dot right there. Whoops, kind of off. There's a dot, -1. And go up 2 over 3. Up 1, 2 over 1, 2, 3. And put a dot right there at the coordinate 3, 1. And of course, you just draw a line right through it. Now, let's talk about the domain and range of this guy. The domain, if you don't remember, are your x values. Now, let's look at the x-axis, which means it's running left and right. Does this blue line that you just graphed, does it go to the right forever? Does it go to the left forever? Yes. So what do we say about the domain, the x values? All real numbers, that's right. So x equals all real numbers. Now it's time for the range. The range are your y values. Now your y values are going up and down. Does this blue line go up forever? Or does it stop at a certain point? It goes up forever. The arrow means it goes up forever. Keeps going this way, keeps going forever, right? How about, does it go down forever? Yeah, it does go down forever. So what do we say about the range? Y equals all real numbers. And that's it. Oh yeah, besides that, it says, is it a function or is it a relation? It's a function. You guys remember the vertical line test? All you got to do is just look at or think about a bunch of vertical lines, and this blue line will never cross at more than one point on these vertical lines. So it passes the vertical line test, so it is a function. Now, if I had something like, let me just do a quick sketch. Let's say I had like a circle, then that would not be a function anymore, because if you draw a vertical line through it, it'll pass at 2 points. So that would be no longer a function, it's just a relation. So yes, even this stuff's coming out on the test. Is everybody cool with point slope form, or should we review that one too? Review it? Okay, point slope form, it kind of is like, oh no, actually, I'm sorry, this is not point slope form, this is vertex form. Confusing algebra 1 with algebra 2. Okay, so this is vertex form. So what is our vertex? That's right, H and K, and we need to remember the vertex form, which is y equals a parentheses x minus h squared plus k. So our h and k are right here and here. Just think opposite of what you see on h. So that'll be a +1 and a +1. Ladies and gentlemen, that's the most important point right there, 1, 1. So let's go to the most important point, which is 1, 1, which is right there. You could also draw your axis of symmetry going right through that vertex. If they asked you for the axis of symmetry equation, it would simply be x equals the x value of your vertex. This one's x, or in other words, x equals h, which is the x value of vertex. So that's your equation of the axis of symmetry. That is the vertical line that goes through the x value of 1. And for more points, all you need to do is make a quick xy table. But you know what? I believe just by looking at this and looking at the a value, is the a value positive or negative? Positive. So that means it's going to be opening up, correct? So just by that, you're going to be able to identify the multiple choice. So I'm sorry for the abrupt finish here. The 1/2, if it were a 1, it would be a 1, 1, 2, 4, but it's not a 1, it's a 1/2, which makes it just slightly wider. Slightly wider, probably not that wide, but that's a sketch right there, and you'll be able to see it on your